we go to integration. So when we have differentiation, so we have opposite operation, integration. If we have addition, we have subtraction. If we have multiplication, we have division. So that is mathematics, which is, if we have left, we have right, we have up, we have down. So that's why from the mathematical equation we can describe something which is help us to make it automation. So actually mathematics come to solve a lot of problem, but now it make you a bit complicated for you, right? Because we just only learn how to solve it. We have integration and so on, so we cannot see the application, we cannot see the beauty of the function, why actually the function come out. So actually this function come out to make easy our life to calculate something which is for example area under the graph. So we do not need to 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 what to calculate manually just by using a formula. So that's why we have integration. So we have this integration. So if we have constant, before this, if we have constant, if we differentiate, we get 0, right? So we get 0. Okay, if we have constant, so if we have constant, for example 50, differentiate 50 with respect to dx, so we will get 0. So now we want to reverse this operation, so we integrate 0 with respect to dx, with respect to x, so equals to c, which is c is come out can be 0 or 15, can be any number, real number, any number, can be any number. So that's why it come out c. But by using definite integral, which is we have value from where to where, so we can find the c value. Okay, we can find the c value. So integrate 1, we get, this is integrate 0, this is actually integrate 1, this is dx. So we will get x plus c. Integrate xn, so we will have this formula. Okay, the most important, which is very confused and tricky one, is integrate 1 over x equals to ln x. But if integrate ln x, okay, integrate ln x with respect to x dx, you will get what? Not sure. You'll get what?
We'll get
Not sure.
X
X.
per D per X or X per C?
X per C. X per C. How come X per C?
Oh, I see.
This is make you confused actually. So almost we give us 1 over X. Actually, this is a wrong answer. So you go to the online internet calculator. Apa? Symbol lab. Symbol lab. Integration, we have a lot of. Okay, we integrate ln x with respect to dx. Go. So you will have ax minus x ln x minus x. So how apply the integration by part. So here they not state that. So maybe you can get another calculator. Ln Control L, integrate. Okay, integrate ln x. Go. Simplify. Dia tulis working tak kat sini? Dia tak ada tulis working lah. Show step. Okay, by using integration by part f uv. So okay, so they actually x ln x minus x plus c. The answer is x ln x minus x. Okay, so the answer is x ln x minus x plus c. You remember here, if integrate ln x, so the answer is not easy as you differentiate. So 1 over x, but actually this by using by part. So later we will learn how to use a by part. So but if we integrate 1 over x, so we will get ln x. Okay, use it. It is similar to log. Integrate log, we get ln. We get x also. But usually we use ln base e. Okay, so integrate ex, so we get ex. So if we integrate ax, a is a number. Actually, then they need to define this is a real number. This is a real number. For example, 5x dx. So you will get 5x over ln 5 plus c. Okay, example. You put the example here, so it's not confused. If not, you confuse a. What is a actually here? And then if you integrate sine, we got negative cos x. So you just remember 1, which is consists of negative. If you remember 2, maybe you confuse later. You just remember 1. The others will be opposite lah, kan? Alright. And then secant square x equals to integrate secant square x, we get tan x. Okay, that is we are usually use. The rest this you use for your application letter. Maybe you deal with this what form, with this kind of function. So you will get tan, and then the rest I think not really use, but we always use this. Okay, you should remember lah, so it is more easier. Alright, so now we go to properties of integral. For addition, how to add two integral, how to subtract two integral. So as usual, it's just easy. If we can add first, or we can integrate and then later after integrate we add the function. It can be both sides is equal. Okay, for example here we separate first, and then after integrate we add this function. For this function we factor out outside, and then we multiply this. So we will have 2 integrate x plus x to the power of 5 bracket dx, and then they separate x and x to the power of 5 and simplify, and then we get this. Definite integral meaning we have value in this integral, so that we can find the c value. So if we have fx is a real value continuous function ab, fx is an antiderivative indefinite integral of fx ab, then we have this. So whatever come here, just put inside the function. Okay, so here we have this. So after we integrate this function, so we the number should be, we close bracket here. So pi over pi from 0 to pi. So until we put the pi and 0 in this function, so we put in this x, so we get x cubed, and then 7 cos 3 pi, and then minus 0, so we put 0 here. We use the same function, so we get this. So no more c, dah tak ada c, because the c here is 14 over 3. Okay, okay, so here also we just multiply first, and then this 2 we put outside, we differentiate, and then we get the numbers. No more c. Okay, so this is cosine, so you need to differentiate cos and sine first, and here you will have, so integrate 2 to 0 1 dx plus integrate x to the power of 4, 0, 1, dx minus x, integrate x, negative 2 over 3 dx. Simplify, then you put the value inside. Okay, so now we have a few techniques to make the integration is more easier. So we have integration by substitution, a change variable. So we change the variable, we calculate du dx and evaluate and replace u with gx. Okay, what is substitution? Substitution, we try to make this function more easier to deal. So what we'll have, so now okay, so we have the function. So we have this function, integrate x square root of x squared plus 1 dx. Okay, so then we have, okay, so now if we differentiate this, okay, if we differentiate this function, so let's say we have u equals to x squared plus 1. We differentiate du respect to dx, so we have 2x d. Okay, 2x, so du equals to over 2x dx. Okay, why I do this? Because here we have x and then we have dx. We can replace it as a du over, so what will happen here? So square integrate square root of u and u, and then we have dx du equals to du over 2. So simplify this function. So you have 1 over 2 integrate, okay, integrate u 1 over 2 du. Alright. Okay, so 1 over 2 u 1 over 2 plus 1 over 1 over 2 1 over 2 1 over 2, right? Okay, we see here, if we have Sn, so n plus 1, so copy n plus 1, so 1 over 2 plus 1, copy everything here, and then plus c. That is substitution. So simplify here, so we have 1 over 2 u 3 over 2, so here we have 3 over 2 plus c. So simplify again, so 2 over 3 u 3 over 2 plus c. So we will have u 3 over 2 over 3 plus c. So what is u? U is x squared plus 1. So u is x squared plus 1 bracket 3 over 2 3 plus c. Okay, here. And and here actually, okay, for the definite integral, we have this, right? We also can have we also can have like this function, definite integral definite integral. So you have okay here. I want to show you slow pula saya punya internet. Okay, you all nampak tak ni?
Nampak?
Nampak kan? Saya pun dah bunyi. Okay, so now if we have a b and then we have fx dx, and then we can separate it. Okay, separate this function by using c, but c is a connection point between a and b, so it's okay. It still can make it as long as the point is touch to the b. So this also can be done lah. So make sure that you not fix that the only A to B only, but we can make it half or make it a few steps so that we can go to the this. So this is one of the properties sometimes we ask in the multiple choice question to make sure you can understand. But in your note, they not stated here. They should modify that actually. Okay, so we go to substitution. So here, so we want to substitute. Okay, cos x as a u. Sorry hari ni pun ada gangguan juga sebab sebenarnya saya dapat MC, anak saya pun demam. Okay, so abaikanlah ada background music tu. Alright, so you akan dapat here, if you have cos x, so we differentiate du with respect to dx, so you get sin x, negative sin x, negative differentiate cos. Okay, you differentiate cos, negative sin x, cos negative sin x. Okay, cos negative sin x. So negative sin x. So now, so we have du, so we don't have sin here. Oh, you need to modify first. Because here we get here this thing, right? Because here we have this thing, so this thing. So du equals to negative sine x dx. So we have dx, but we don't have sine x here. So how to make this is a sine x? So we need to using the identity. We need to use identity. What? Trigonometry identity. The keyword is trigonometric identity. It's in here. So we have sine x, cos square. Cos square equals to this one. So we have this one. So here we use this identity. So when we use the identity, so what will happen? We modify this first. We separate. So cos square. So cos square is 1 minus sine square x. So and then we multiply after we what we change this by trigonometry identity. Okay, trigonometry identity, and then we multiply this and this. So that's how you get this. Alright, and then we got this. So we have sine square. So now we use again substitution. So we get the cos x. Du equals to cos x. So from here we got cos x with cos x. So we get just only. So the point here 2 times substitution. Okay, and then once we got this simple function, then we integrate as usual, and then we replace u equals to sine x, sine cube x plus c. So 2 times substitution. So you can try this, and then we rest. We go to the substitution by part, and then we have another one is partial fraction. Okay, we can we rest around 15 minutes. Okay, and you can try here as your attendance. You try this. Is it okay? You can try this. Boleh? Boleh tak?
Boleh, madam, boleh.
Alright, okay. We try this.
Yes, madam.
Okey kelas. Kalau buat macam ni, hilang markah ni.
Ya.
Hilang markah ni.
Dalam awak itu.
Ah?
Kalau itu hilang kau.
Ah? Hilang markah dekat sini ada markah differentiation. So yang ni you dapat sebab you tak buat du over dx. You kena buat ni. Equals to 2x. Sini tak ada kan? Dia terus masuk. Yang ni ada sini ada markah sini. Sini ada markah. And then yang lain baiki tulisan je lah. Tu je. Baik, sekejap. You tak boleh separate kan dia ni. Sebab dia ada x kat sini. Okay, boleh. Sebab you pakai substitution ni. Apa you buat ni? Kejap. Dia saya dia jadi macam dua function berbeza tau ni. Confuse sangat sini. Okay. Bracket kan dia. Meaning dia term yang sama. Yang ni dia akan jadi dua term yang berbeza. So hati-hati kat situ. Okay. So bracket kan dia. And then you buat satu. Okay. Nak macam ni. Nampak dia punya kekemasan menulis tu. Nampaklah step dia kan. 90, RK90 tak buat apa-apa. Dia tau. Kakak duduk sini dengan adik. Kakak duduk sini. Kakak duduk dengan adik. Okay. Alright. Okay. Okay. Nice. Okay, next kita pergi ke partial fraction. Partial by part, sorry. By part first. Okay, by part. So by part is we use this formula. We have integrate u dv equals to uv minus integrate v du. So when we want to use a by part, when the function we cannot differentiate integrate it directly, and then by using substitution we cannot substitute anything. It's like what, even we use substitution. For example, here we use substitution u equals to 2x. So here we have x, so it's quite difficult. Okay, so it's quite difficult there. So difficult and cannot be integrate. So that's why we use partial. So partial is we let something u and we let something v. So what is u, what is v? So u is equals to ln x, v equals to dx, v prime here, meaning we already differentiate the v. So dx equals to whatever pair with the dx, so we have v. So now from here, for u we differentiate u, for v prime we integrate this function v. So we integrate v, we integrate v prime, we got x. We differentiate u, so 1 over x. So this is quite difficult lah here. Just make sure you remember how to use this. Okay. And then by using the formula here, okay, we have this formula. So we already have u, we already have v prime, we have du, we have dv. So by using by using formula, okay, by using formula, so we can see here. We use formula. Okay, we use formula. So uv is u, uv ni sebenarnya uv minus v minus v du uv okay, saya uv minus v du. Okay, so now what is our uv? Okay, so u, what is u? U is here. Kan? U is ln x. Okay, u is ln x. And then we take u, v. V is x. V is x. So, so it's more easier to put x ln x. V. And then v. What is v? V is x. Okay. We copy again v minus v actually x. So du, what is du? Du is is du is here. Du is equals to 1 minute. Okay, dx over x. So dx over x. So you can eliminate there. So you get x ln x minus so you just get negative x plus c. Okay. And for the next question is you let u equals to x squared, v prime equals to cos 2x. So you get this, and then you arrange with the formula. You get uv minus integrate v du. Okay. Alright. And then here we need to apply the 2 times by part, because there is square. If you get cube, so you need to use 3 times. Okay. And then after that you get the answer. Okay, let's try the exercise. Can you try by your own first? Here, you need to use two times by part. You can try this example. Okay, so we have what? We have x ln x. So we want to identify what is u. So what is u? We need to replace. So just u is f here. So u equals to ln x. So what I make here is will be, maybe we get a long what? A long step lah. So ln x. So du differentiate ln x, we got 1 over x dx. And then v equals to g prime, which is equals to x, which is equals to x. So here v equals to x dx. Alright, and then we will get, okay, integrate this. So v equals to x square over 2. So uv minus v du. So u is ln x, v equals to x square over 2 minus ln v. Integrate v. What is v? V is x square over 2 du. du equals to 1 over x dx. So we will get x square over 2 ln x minus integrate 1 over 2 x dx. Okay, so you get x square over 2 ln x minus 1 over 2 x square over 2 plus c. So x square ln x over 2 minus x square over 4 plus c. So if you go to the calculator, they combine x square ni. So that's why it's come is here you get 2. Okay, you get 2. Alright. Okay. So here they put 4, so just combine all everything. So and then they factor out x square. Okay class, I think that's all for today. So partial fraction maybe later. Maybe this Wednesday. Is it okay? Partial fraction this Wednesday?
Okay, madam.
Alright. So thank you for attending my class today. Okay, thank you. Assalamualaikum.
Thank you, doctor.